Hello, everyone, and welcome to the Varsity Tutors Star Course series, where today we are over the moon to be joined by our friends at the Denver Museum of Nature and Science. Today, we'll be looking at the importance of that A for the arts in the acronym STEAM and seeing how we can illustrate some important scientific concepts using actual illustration. Now, before I turn it over to our host for today's lesson, Robin, there are a few things I want you all to keep in mind. First off, to follow along with today's activity, you'll want to have the materials that are listed on that course description site handy. So that's going to be a piece of orange paper, a black pencil, and a white pencil. But as long as you have something to write on and something to write with, you'll be able to follow along with today's activity. You also may find that you have some questions throughout today's lesson, and Robin's going to have some questions for you too. So feel free to use the chat function on the right-hand side of your screen to both ask and answer questions throughout the lesson. And if we don't get to those questions right away, we're going to save about 10 minutes at the end of the lesson for Q&A, so we can hang tight on those questions until then. Now, you'll also want to be sure that you have your cameras handy, because toward the end of the lesson, we're also going to have the opportunity to lean into the screen and pose for a selfie, and potentially pose for a selfie with that artwork you've created if you follow along today. And if you tag us here at Varsity Tutors and the Denver Museum on Instagram, you'll be entered to win a 1-month subscription to the after-school club of your choice. Now, we'll talk a little bit more about that prize and how to enter toward the end of today's lesson, but for now, let's pass things along to our instructor for today, Robin. Take it away, Robin.
All right, hey everybody. I hope you're having a great day so far. Like she said, my name is Robin, and I'm an educator and a scientist here at the Denver Museum of Nature and Science. And I have the privilege of bringing some real science to you, coupled with some art. So if you love art and you love science, today is going to be your lucky day. All right, there are going to be some times where I'm going to show you some actual photos of real images out in space, which is really cool, right? So we're going to use that data to draw a picture of this amazing place. So I don't want to give away any of the exciting stuff ahead of us. I want you to see it. So let's go ahead and get started. All right, so here behind me, and I'm going to disappear so you can see this a little bit better. This is a planet. And I bet you recognize what planet this is. There are kind of some clues that give away what planet it is. And if you are thinking Saturn, you are absolutely right. So in 1997, a spacecraft called Cassini was launched to study this planet. It took 6 years and 9 months to make this trip. And we're going to go a little bit closer to not Saturn, but this moon of Saturn. All right, so we're going to go a little bit closer, and you're probably noticing some cool stuff about this moon. Does it look like the moon of Earth? Well, not really, right? It's a little bit different. It's an awesome color, orange. And we're going to talk about why it's orange in just a little bit, right? So how many moons do we have here on our planet? Just one. And what do we call it? The moon. But on Saturn, they know, or they have discovered, at least 63 moons. This moon that we are going to study is called Titan. And it is the second largest moon in our whole solar system. The first one is Jupiter's moon. And Titan is really cool for a number of reasons. Number one, it's orange. It has an atmosphere, which is basically why we see that it's orange. And that's why we are using orange paper today, right? It's orange because of these amazing hydrocarbon molecules. And we're going to talk about that in a little bit, but let's learn a little bit more. Let's get more of that data so that when we do our scientific illustration, we're not just coming up with random things. We actually know a little bit about this moon that we're going to draw the landscape of. All right, so this was a probe. They took data for 13 years, and in 2004, they sent this probe onto the surface of Titan. So you might be noticing some things you recognize. This is the probe's actual video footage. All right, what do those look like? Some of you might live in a place where there are landforms like that. Oh, we just went through some cloudy haze. And now we're right on top of the surface. That shadow is actually the parachute that allowed that probe to come down to the surface without busting into a bazillion pieces. So I hope that you notice those landforms. They kind of look like mountains, right? So we know that there are mountains on Titan. Maybe you saw some rocks that are sitting on the surface of that moon. And we are just going to go ahead and get started with our drawing because it takes a little bit of time. Don't be intimidated about the drawing. I'm going to walk you through all of it. And I don't really consider, I'm certainly not a professional artist. I'm a biologist. But drawing this landscape is pretty awesome because we all use the same data and our pictures come out sort of unique to us, but they all are accurate because we're using these real photos. And with that being said, you can see here in this, we've got Saturn, and then one of Saturn's moons, the biggest one is Titan. It's actually like half again bigger than our moon. So it's really, really amazing. All right, so let's start by drawing the horizon line. And when you hear the word horizon, maybe you're thinking it's a flat line going across this way, right? Horizontal versus vertical. So, and basically it's just a line that's going to separate the sky from the ground. This is my paper. It's only big because I want you to be able to see what I'm doing. So think about your paper and we're going to divide it into 3 parts. So you can think of 1, 2, and 3. And we want our horizon line kind of down right over here, a little bit less than third, but not as much as a half. So I'm just going to, and it doesn't have to be completely straight across. All right, so just about like that. And it wasn't entirely flat, right? When we saw that video footage, it wasn't entirely flat. So it's okay that mine dips down here a little bit too. Okay, so hopefully that didn't take you very long to do that. The next piece we're going to look at, we're going to go into a little bit more details of some of those pictures, that actual footage that we saw. And that's these mountains. Let's get you a better perspective here. All right, does anybody have a guess about, do you think they're as tall as the mountains on Earth? Do you think they're smaller than a lot of the mountains on Earth? I mean, we have a lot of different size of mountains, height of mountains too, but there can be peaks that are actually 10,000 feet. And I want you to think about, we're doing a lot of comparing and contrasting with the planet that we know best, which is Earth. What are the mountains made of here on Earth? Any guesses? Right, rocks and minerals. So the mountains on Titan are actually made of water. Whoa, does that blow your mind a little bit? It kind of does me. How could water be hard or as solid enough to actually form a 10,000 peak mountain? Well, let's think of the temperature. So, right, so now we get to think about, where is Earth compared to Saturn in relationship to the sun? So you maybe know the order of the planets, right? So with the sun, we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn. Whoa, so Saturn is a lot farther from the sun than Earth is. So how would we expect it to affect the temperature? You think it would be warmer on Titan or Saturn, or do you think it would be colder? Yeah, so it's a lot farther away, so it is way, 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 way colder. It's actually, on average, about -300 degrees Fahrenheit. So I live in Colorado, And last week we had some temperatures that were, oh, it was kind of cold. I felt it was cold, around in the 20s. And that made my skin feel cold. So what would happen if you were at negative 300 degrees? Yeah, we couldn't survive, could we? But one of the things that does excite scientists about the moon Titan is, number one, it has the atmosphere. Number two, it has those hydrocarbons that make it that orange color. And they think that those carbons might be the building blocks of life. So we're always wondering, could there be, even if there isn't now, could there be life eventually on another planet, or in this case, another moon? So I always think that's something cool to think about. All right, so we've got our horizon line. We just saw some amazing mountains. So that's our scientific evidence to put mountains on our landscape. So when I draw a mountain, are these like rolling hills that are rounded, or are they really, really pointy? Well, you can see these peaks are very pointy. So much so that when I draw, I'm actually going to make basically an upside down V for a couple of them. Okay, so I'm going to start by drawing the mountains. And I'm going to come all the way down like that to the horizon line. And I'm going to use, this is kind of about perspective, right? So these are kind of far away, but the ones in the back, I'm going to put my line at the tip of my marker, right? Kind of put it behind. You can see that perspective there, that I didn't draw this whole thing like a triangle again. I drew it with this part would be behind that mountain. I'm going to leave a small space right here because we're going to put something else there in a little bit. If you need to put your finger there when you draw that, go ahead and do that. I'm going to use my hand because my paper is so much bigger. And then I'm going to draw a couple more mountains here. And then maybe another. Actually, you can change your mind right in the middle of drawing. I'm going to put a bigger one way in the back and maybe another one right here. Okay. All right, looks pretty good. I feel pretty happy with that. So remember, these mountains are made of water, solid water ice at negative 300 degrees. Okay. Hopefully you've had enough time to draw your mountains. We're going to move on to that next landform. So we have plenty of time to make this amazing picture today. And right up here, think about if you are looking down on something, maybe you're in an airplane. In this case, this was coming from, a spacecraft, a probe. And think, so we're really, really high in the air. There's something on the surface here. So these are actually rivers. These are rivers. All right, so we're going to put a river on our landscape. Now, if water on Titan is so cold and so solid that it can be a mountain, what do you think the rivers might be made of? Any ideas? Right? Remember what we talked about that makes Titan orange? It's those hydrocarbons, that carbon and hydrogen molecule. So in this case, it's actually methane, right? Maybe you've heard of methane before. There are other hydrocarbons that are on Titan as well. And they all kind of end with the last bit of ane. So propane, that's what we use in our gas grills if you have a barbecue. Ethane, butane. Sometimes people will light butane on fire if you needed to have fire for any reason. But methane, have you heard of methane before? There are numerous sources of methane. One of them is from raising livestock. So cows eat grass, they digest it, right? And then they produce gas, right? So it's basically cow farts. Methane, one source of methane is from cow farts. There are other sources too. So transportation, that causes about a third of our methane. And on Earth, methane is a greenhouse gas, which means it holds on to that radiant energy from the sun, kind of warms things up, and our atmosphere holds it in, right? The air on Earth holds it in. On Titan, it's actually an anti-greenhouse moon because there's so much haze, there's so much thick atmosphere that it blocks some of that radiant energy from the sun. Okay, so let's make our river. And remember, it's a methane river, so methane can be liquid on Titan. All right, so perspective again. Things that are way far away are going to look smaller than things that are up close. So this is way far back on our picture. Up here, it's going to be close. So I'm going to start by making a curved line, kind of like this. All right, so the first one's pretty easy because then it can kind of go anywhere here in this open space. But this one, you're going to start out with those lines close together, and then they get farther apart and farther apart and farther apart to create that perspective. Kind of looks like a road, doesn't it? But it's actually that methane river. And maybe you've learned about the water cycle here on this planet. So what does a water cycle mean? Well, it means that water can exist as a solid, it can exist as a liquid, and it can exist as a gas, right? So we've got snow, we've got lakes and oceans, and then we have water vapor. When the surface water gets heated up by the sun, it evaporates, and then this whole cycle happens over and over again. There's also a cycle on Titan, but I bet you can guess what it is, right? What is liquid on Titan? It's that methane. So we're going to talk about that, looking at some of our next landforms. All right, so let's look here. So that was our river. And, ooh, what are those? So let's look at them a little closer. So they're all kind of the same thing, but do they look exactly the same? Nope, not at all. So they are rocks. And just like on Earth, there's going to be some differences. Mountains on Earth are made of minerals. Rocks on Earth are made of minerals. So mountains on Titan are made of water, right? Solid water. So what do you think the rocks are going to be made of? Now, I bet you got it. Water, solid water, H2O. All right, so this is the part when I have to tell my scientific brain to be more of an artist. So we naturally kind of want to see patterns and make things make sense in our brains. But you can see in nature, not all these rocks look alike. Some of them are kind of pointy and rounded up. And you can see the bottom part is actually below the surface. Okay, so we don't get to see the whole rock because some of it's buried. Some are sort of flat. These way far in the distance are smaller to our eye. If you got to see them up close, they would look bigger. So we're going to do the same thing on our landscape. Don't drop too many rocks because we've got some things to add the details. And if you add lots of rocks, it'll take you a lot more time. All right, so I'm going to make maybe 5 or 6 rocks on my picture. So I'm going to start over here. This is sort of, I think about, right, small, medium, and large. So the small ones are going to be pretty easy. Right, and I'm not going to do too many over here because we're going to put something else. This is the spot where we're not going to put any rocks. But I'll maybe do a medium-sized rock here. So see how I left this bottom part nice and flat? I'll do a bigger one so you can see that better. All right, so this one here, kind of pointy, like that. And this is the part where I say, don't make them all look the same, Robin, because those kind of look the same. So I'm going to make one nice and flat, like that. And same thing over here. maybe do, oh, that's a different looking rock. Oh, and then a medium-sized rock over here. And then I'm going to put a few more in the background, maybe a teeny tiny one here. And I feel pretty good about that. I feel pretty good about the number of rocks. It's kind of starting to look like something now. This is a part where it gets exciting for me because it's like, oh, we've got mountains, we've got a river, we've got some rocks, and it looks a bit like a true landscape. Okay, you're probably done because you didn't have to draw too many rocks. So let's look at the next piece. Ooh, this is a good picture. So this is that moon again, Titan, but we're talking about these white wispy things, right? What's white and wispy? If we look up into our sky, clouds. So that's why we were talking about the methane cycle, because it's negative 300 and at that temperature, and there's some variation, right? So it's going to warm up a little, and that methane in the rivers is going to float up. It's going to go into the atmosphere, and it's going to form a cloud. So we're going to make some wispy clouds. They're not those big, fluffy, like cumulus clouds that we have on Earth. These are sort of the wispy variety. And I always like, this is the part where I'm like, ooh, I'm a real artist. I'm going to put a cloud behind one of my mountain peaks. So this part of the mountain is actually hiding the cloud. Right? And I'll make another cloud over here. And maybe a smaller one right next to it, like that. Okay. That looks pretty good. I'm feeling good about that. All right, there's one more thing that we're going to add to our drawing before we start adding those details. Okay, that's the stuff that's going to make it pop. They're right here. So once again, we're way, way, way above the surface, and you're looking down. Doesn't really look like the rivers, does it? All right, you can take a guess if you want. And if you said, hey, those look like a bunch of lakes, you're absolutely right. So it's that methane cycle. So we've got our gas and our liquid, and we've got another liquid over here. And then if it happens to get really, really cold, it doesn't happen very often, methane can be a solid. But we're going to make a lake. And the way that I like to draw my lakes is you sort of have like a straighter or more of a horizontal line in the back. And then you can add your variations, your curves in the front. So let's see. I'll show you what I'm talking about. So straighter in the back, and then kind of those curvy lines like that. Okay. So now it looks really two-dimensional, doesn't it? It's really flat. We're not seeing a lot of things that look like they're coming out at us like we want for a landscape. This is the cool part when we get to use light and shadow. And you have to pick a point on your drawing whenever you're making a landscape with light and shadow. Do I want my sun to come from this side, or do I want my sun to come from over this side? So here in my example, you can see the highlight is right here on this part of Saturn and this part of Titan. And then the dark part, the shadow, is on the other side. So that means my sun is shining over from this way, right? And that's what's creating that amazing light. The thing about Titan and the thing about Saturn is because it's a lot farther from the sun than our planet is, the shadows aren't and the highlights aren't going to be quite as strong. It's actually about 10% of that. Oh, I just forgot something, but actually, yeah, we should add this in now. Because of the methane cycle and the way that the methane gets to the surface of Titan, it has to rain. So our clouds, when enough of the methane gets up into the clouds, it gets super saturated and then it has to fall down. So we need to add the rain before we add the shadows. All right, and on Titan, there's not as much gravity as there is here on Earth either. So the rain falls really, really, really slowly to the surface, which I think would be amazing to see. All right, let's go ahead and I just do like little sort of dashes like that when I do the rain. And I suppose maybe your landscape, if you can always choose to have it not be a rainy day, but I always like to add rain so that you remember that, oh yeah, it does rain on Saturn. Or I mean, it rains on Titan. Okay. Perfect. You might be wondering too, like, well, where does all that methane come from? They don't have cows, they don't have cars, they are not growing things, there are no people, but they think that there might be volcanoes, like ice volcanoes under the surface that are just kind of belching this methane out continuously. So that might be why it's so hazy there. Lots of speculation. We didn't have a lot of time to really study Titan just because that probe was only there for less than 3 hours to take that video data. Okay, I think we've got everything now. That looks good. Now we get to add some shadows. Awesome. All right, so let's pretend that the sun is coming from over here. So we're going to start with the shadows. So you're still using your darker pencil. And when I add shadows to the mountains, we're going to go in the order that we put these on our paper. So I kind of think of like a triangle, and I'll show you what I mean. So, well, not with that one, I won't. So yeah, just like this. So you start out wide and then you get a little smaller and a little smaller and a little smaller, like that. Ah, doesn't that make such a difference right away? It's like, oh, it really looks like a mountain now instead of just a triangle. So I'm just going to do that to all of my mountains. So you are working with me. Just follow along. And there's no real right way to, you may have more shadows on yours than I do, and that's perfectly fine. So, and this one I had some liberty to make either, I mean, I could have done a lot of shadow here or just a small amount like I did. And back here, I feel like this one's probably got a lot. Okay. Do you see how important it is that you put the shadows on the same side? Because if you chose to put shadows here on this side and then maybe over here on this side, then your brain would say, nope, that's not right. That's not how the sun works. All right, so I've got 2 more mountains to work with here. And I think that this part for me is really fun just because we've got all that scientific evidence, and now it's that piece that just kind of makes it look extra special. All right, let's keep on moving. So we've got the mountains with the shadows. And what was our next piece that we did? The river. All right, so we're going to add this one. You have to think about if the sun is shining here, that means it's actually going to hit on this side of our river. So think about the river kind of dips down. So the shadow is going to be right here. And remember that perspective, it's wider at the bottom. I'm going to try to get the bigger edge of my marker here. And then it gets more narrow as you get closer to the mountains. Okay, that looks good. I'm pretty nice to myself too about my drawing. I feel like, you know, I'm doing my best here. I think this is going to be good enough to hang up in my house. Okay. So now you can really imagine that this is not flat, right? The river has some depth to it. So that's what we're doing. We're creating depth and texture. All right, the next piece is going to be the rocks. And the rocks sort of leave a little, they almost look like they have a little tail because the sun is shining and it's casting this little rock shadow on this side. And these rocks are not completely flat on top, so maybe there's some shadows like that. Okay, maybe a little more. Kind of adds a little interest. Oh yeah, that looked a lot better. When I added that shadow in the middle, that really kicked it up. All right, make a little tail, little shadow here for this little one. And then these are too small. We don't have to mess around with them at all. They look perfect as they are. And over here, same deal. And you can get pretty technical, so think about it. If it's a really tall rock, what kind of shadow would it leave versus a flat rock? Right? Artists think about those kind of things all the time. There's always a method to what you're doing. Okay, this guy, probably not much of a shadow, this flat rock. And one left. And it's going to be the biggest, this is the big one, biggest shadow of them all. Okay. Woohoo! All right, it's looking pretty good. It's looking pretty good. We still have a few more things to add some shadows to. So let's keep going. How about the clouds? So remember, they were full of methane, so let's add just a little bit of darkness. Think about what happens on Earth when we're starting to get storm clouds rolling in. They're not the same color, are they? A little different. Okay. A little bit of just some flecks of some shadows so they don't all look the same. Don't make them look the same, Robin. All right. Did we shadow everything? Not quite. We need to put shadow on the lake. And we want our lake to look like it has some depth to it. That really, really, really cold methane. So you just do that by adding straight lines. Different lengths. You don't want them all to be the same length. You can do too short and then maybe some longer ones. And you can kind of see I do like a little flick with my hand when I'm doing that, just so this part here that really shows the depth has just a little bit of a thinner tip on it. And you can do that by holding your pencil, like with a really light grip. Okay. Woohoo! It's looking good. All right, I'm going to put this one down because then now we get to add some beautiful highlight to all of our landforms on Titan. So you may have white, you might have yellow, you might have the same thing. If you have the same pencil, maybe you're using a pencil, just use a lighter touch, right? Like almost barely anything. So I have black and white, so it's a little bit easier to see that contrast, but that's what it is. It's all about one of them is darker, one of them is less dark, basically. So it's almost exactly the opposite, right? So our highlight over here is going to be another one of those triangles that's going to go in this direction, and it's going to be that lighter color. And this part, I don't have to talk you through quite as much because we've already done it when we did our shadows. And we're taking a little bit of artistic license in that, like I said, because it's so far from the sun, there's not going to be quite as much highlight and quite as much shadow as maybe here on this planet. But for the sake of our drawing, we really want that texture. We want these to look like they're three-dimensional and not two-dimensional. And I have to say, when I step back from my drawing and I look from a distance, I'm like, looks pretty good. I'm pretty impressed with it. All right, so the next piece that we did was the river. So we're going to add our highlight on this side. And some of the riverbeds that they saw and were able to analyze later were dry. Do we have dry riverbeds here on Earth? Yeah, sometimes. There are times during the year where I live that in the spring where the snow is melting and those rivers are really, really full and the water is really coming down like rapids. And then there are times when it kind of dries out. Like now, in the wintertime. Do you think that there are seasons on Titan? Yeah, there absolutely are. They are different timelines. So if you think about what we know as Earth years and Earth days and Earth hours, so on average, our seasons are somewhere around what would you say, like 3 months, depending on where you live. Where I live, they're pretty easy to define: summer, fall, winter, and spring. On Titan, they're about 7 years long. So if you picked your favorite season and then you had a season you didn't like, it would be a long 7 years, wouldn't it? But it's the same thing about how the rotation, right? So since this is a moon that's rotating around a planet, Saturn, how long does it take Saturn to go around the moon? Saturn to go around the sun. So ours, we just say a year, which is 365 days. But Saturn, it takes 29 Earth years to orbit around the sun. So that's another thing that's kind of different. All right, let's keep adding our highlights. So we're going to highlight the rocks. And that doesn't take hardly any time at all. But super fun. And the clouds. So just a little wispiness. And I kind of do like little curly cues with my highlight, depending on what you are using for a tool. Maybe you're using a crayon, or maybe you're using a colored pencil. And it makes sense. Different mediums have different, sort of gives a different appearance. But this one's a crayon, so it's super easy to use. And then the last piece is going to be to highlight our lake. And it's the same thing. We just use these really soft, kind of thin lines to just say, hey, if you were to jump in that lake, number one, it'd be really cold. But number two, you would actually be able to jump in because it's deep with all that methane. All right, we've got just about 2 minutes to add some labels. This helps me remember, hey, what did I just do? So I like to put the name of this moon. Hopefully you all know the name is Titan. So I'm going to put the name Titan right here. Geez, I should just ditch that one. All right, so Titan. All right, it's a moon. Hopefully you know what it belongs to as well, right? Belongs to Saturn. And if you wanted to get really artsy, you could even draw Saturn right here. We'll see, maybe at the end of our class today, if we have time, I'll just pop in a little Saturn there. All right, but I like to remember it's negative 300 degrees Fahrenheit. So I'm going to write that on there. I like to remember what these rivers and rocks are made of. So methane, we got a methane lake, and that's Methane. And if you wanted to write that out in its atomic formula, that is CH4. And what else is made of methane here? Oh, this river. And this cloud, these clouds. Okay, so that's what we've got, that's methane. What do we have that's made of solid, really, 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 really cold water? The mountains. So we've got H2O is the formula for water. And so sometimes I like to write ice too, so you don't forget, like, oh yeah, that makes sense. Same thing with the rocks. And this is up to you. If you don't want to add these labels, it's your drawing. Okay. Did we label it all? I think so. And then the important part too is like, you did this, so let's put your name on there. My name's Robin, so I'm just gonna put my signature down there. It's 2022, oh my gosh, crazy. So I'll put that on there. So when somebody comes to my house and they're gonna look at that and say, oh my gosh, who did that? I'm gonna say, I did. I'm the artist here. Okay. How are you all feeling about your landscape? I hope that you're feeling really proud of yourself, right? Give yourself a pat on the back. There's going to be a few minutes of time for the questions and hopefully some answers. Think about those if you haven't done the chat yet. And then we're going to do some of the other fun stuff now. Oh, wait, I want to show you one more thing. If you want to be a scientific illustrator when you grow up, maybe you do. I'll see if I can get that to come up. I'm having some technical difficulties. So in the meantime, I think Haley will be able to talk to you.
All right, awesome. So while we wait to get that situated, I think it is about time for that selfie. Now, if you haven't gotten the chance to wrap up your Titan masterpiece just yet, not to worry. We will have this recording available on YouTube so that you're more than welcome to follow along step by step, pause where needed. But for those of you who did get a chance to complete it, by all means, feel free to include that masterpiece in your selfie. Now, as a quick reminder, if you post those selfies to Instagram and you tag us here at Varsity Tutors and the Denver Museum, you'll be entered to win a 1-month subscription to the after-school club of your choice. So whether you enjoyed this class because you got to sketch things out and you might like Sketchmasters Club, or maybe you liked the STEAM and science end of things and would be interested in Curious World, or maybe you want to look at something else that's out of this world entirely and you're interested in that Cosmic Adventure Club, there is a club for you. Now, don't forget to go ahead and post those selfies. And in the meantime, I'm going to hand it over to Robin to show off her masterpiece.
Yeah, so this is an actual artist who gets paid to do this amazing scientific illustration. His name is Michael Carroll, and he had the same data that we did. He looked at the same pictures because they were from that probe that landed way back in 2004. And so this is what he thought Titan looked like. Let's let you look out a little bit bigger. And what do we see here? So mostly it looks like he did a lot of lake. You can see a lot of methane, but oh, look at he added some waves to his illustration. And then he kind of chose to make his mountain range. It's a little, I guess I would say there are more mountains, maybe not quite as pointy as what we did, but isn't that cool? And that haze, that color of this picture is amazing too. A little bit more variation than we got to do with our orange. So yeah, pretty cool.
That is so cool. And hopefully everyone had a chance to snap those selfies. If you didn't, we'll be here just a few more minutes and Robin will be continuing to show off her artwork there. So you're welcome to take a picture at any time. We had lots of really great information around similarities and differences between Titan and Earth. And we had lots of very wonderful, very specific questions about those similarities and differences. Which one's bigger? Which one's smaller? What is the temperature like? What are the seasons like? So maybe we could wrap all of that together into a couple of your favorite highlights to recap similarities and differences between Earth and Titan that we studied today.
Yeah, I think the first thing that was sort of amazing to me is that they both do have seasons. Our seasons are kind of short and sweet in some ways, 3 months. Their seasons are about 7 Earth years long. But One, we are a planet, right? And Titan is a moon. So that's kind of a big difference right there too. You think about what's happening on our moon. Does our moon have an atmosphere? No, right? There's no wind, there's no rain, there's nothing on our moon. But Titan has all of those things, and it's just because of kind of where it's located, and the size of that moon has a lot to do with it too. Its size is great enough that it allows it to hold onto the atmosphere, right? There's air. We have lots of different molecules in our air. We've got oxygen. Is there oxygen on Titan? No, there's no oxygen gas. So that's kind of a big difference. That's a big highlight. We have nitrogen. They have tons of nitrogen. Most of their atmosphere actually is made of nitrogen. And then there's that methane cycle. So we call that a triple point. Ours is water here on Earth. Their triple point molecule is methane. All right. And then I think the other thing that every time I think about it is you think of our gravity, the force that's holding us onto this planet. The gravity on this moon Titan is very weak compared to ours. So that means that when things are falling, they just fall really, really slowly.
Awesome. Now, we also had some students who caught that you mentioned that when you're not creating masterpieces about Titan, you are also a scientist. So what sorts of things do you or does the team at the museum as a whole like to study, and what other sorts of things do you exhibit?
You know, our museum has like basically 3 or 4 main areas. Space is one. We have an exhibit about the body. And then we have a gallery we call Prehistoric Journey, which is all about when our planet was first formed, and then the different stages of life that happened from that point on. So we've got fossils of dinosaurs, and we've got fossils of Ice Age animals like a mammoth and a saber-toothed tiger, and just some really cool stuff like that. But to your point, we can all be scientists. To be a scientist, it just means that you're curious about the world that you live in and kind of the space that could be around our world too, right? So there are space scientists, and there are people who study the body, and even astrobiologists. So the people that were interested in, could there be life on Titan? That's what you call an astrobiologist. There are lots of different things. Do you have to be a scientist as a career? Absolutely not. If you're a curious person, that automatically makes you a scientist.
Awesome. And we had another pretty specific question, but to make it a little bit more general, we had some students wondering where Titan got its name. So could you talk to us a little bit generally about how moons and planets and other objects in space come to get the names that they have?
Yeah, absolutely. So I always like to remind myself, right? So a planet is a celestial body that orbits around the sun. A moon is the same thing that orbits around a planet. And there have been people interested in the things in the sky, really probably since there were people on this planet. So usually if you discover something, you get to name it. All right. The name Titan, oh gosh, that is one that actually stumps me. I do know that the person who discovered Titan, that's who got the probe, the Huygens probe that they sent to Titan, was who actually, it was named for him. His name was Christian Huygens, and he discovered Titan in 1655. So that was a long time ago. It's hard to imagine really that there were tools that were amazingly, detailed and strong enough, I guess, to see that far. So I'm trying to think if I know where Titan got its name. That might be a research topic that you can look up after we're done with our class. I'm sorry about that.
That is quite all right. And I know there are plenty of very cool stories and, elements in history to be had if we take a look at not just, what we've learned about different planets and other bodies out in space, but also where they got their names. Now,
Yeah.
it is about that time. So just as one final question, we have lots of aspiring scientists, maybe aspiring artists in the class today who are wondering if they're interested in learning more, interested in pursuing as a field of study, the sciences at large, knowing that STEAM, right, our science, technology, arts, it is all going to concern a lot of different variety of skills, just like we saw today. So what sorts of advice, what sorts of skills would you suggest for students who are interested in learning more about science?
I think it comes from having that curious mind, and like you really want to answer those questions that you have, like, why does something do this? Where did it come from? Right? What does it make you wonder? Or have you seen something that looks like that before? Those kind of inquiry-based questions that you're asking yourself. Obviously, there are places that you can go to if there's a specific subject that you want to learn more about. You don't even have to commit to maybe taking a class at a school. Libraries sometimes have classes. We have opportunities here at the museum with camps and fun things where you can learn about space and dinosaurs and things like that for just a week. And I would say just talking to people in your community. There are even, just like you're doing right now, opportunities online where you can, our website, our museum has scientists that will come on, and you can sign up for virtual programs and really learn from people who have a passion for a specific subject. You don't even have to dig very deep to find classes and other people to listen to. And I think really for me, that personal connection, listening to someone who has had some experience, is excited about what it is that they're going to teach. And it can spark things that you never even thought of before, which I think is especially cool. I remember listening to somebody talk about like a specific I took a class about rocks, and I wasn't somebody who was by nature like super, super excited about rocks. But after I took this class and I learned about different ways that you can look at them and different ways that you can test to see what kind of minerals are in the rocks, where you can put chemicals on them and see if they bubble. Like, it just opened up my mind to how cool something was, because I just didn't know enough about it before. Yeah, so I would say being curious and then taking that next step to satisfy that curiosity with learning from other people, or going to the library and picking up books on this specific subject, if that might be an option for you too.
Awesome. Well, thank you so much once again, Robin. I know we also had a couple of questions on details for posting that selfie. We definitely want to see all of your wonderful Titan artwork. So we'll have the details up on screen in just a moment. But really quickly before then, thank you so much once again to Robin and to the entire team at the Denver Museum. Thank you for all of you who tuned in and asked such wonderful, thoughtful questions. And speaking of opportunities to learn more, we're going to be rejoined by the Denver Museum in February for a very timely, I guess just in time for Valentine's Day, opportunity to learn about the heart with a virtual heart dissection. So if you enjoyed today's class, definitely check out that class page and sign up. In the meantime, we hope to see you all in another Varsity Tutors Star course soon, and we can't wait to see those selfies. Thanks so much, everybody.
All right, everybody, stay healthy and stay curious.